So today's video is going to be a step-by-step tutorial on how to use the INA260 DC power and current monitor from Adafruit with an Arduino and an LCD display. This video will provide you with everything you need to know on how to use this, from installing the libraries, to modifying the code to meet your specific needs, to how to measure a load, and finally, to top it all off, how to output the data to an LCD display. So the INA260 is a precision DC current and power monitor, and to a certain extent it's also a voltmeter, which can measure up to 36 volts and 15 amps continuous. And as if that wasn't crazy enough, it can do all of that with an insane level of precision, making this perfect for high power projects that require power monitoring, or even when building something as simple as a watt meter. Getting started with the INA260 is so easy because everything is already calibrated and all of the communications are done over I2C, so you don't even need that many wires to get it started. And this is honestly one of the most useful devices I have gotten for Arduino, because you have no idea how much time I would spend trying to get these stupid voltage sensors to work with their analog reads and their resistor dividers. Little did I know how easy it was to take measurements using these new devices. So let me show you how to set it up fast. So all you need to get started are 6 jumper cables, one INA260 board, an Arduino Uno, Mega, or Nano, and of course, a breadboard. And if you're going to be measuring things over 2 amps, it helps to have a little flathead screwdriver so that you can undo the little headers here and put in the wires so that you're not sending all of that current through your breadboard. And lastly, if this is going to be used with a battery, it's highly suggested to have some sort of fuse in place. Now, this has a maximum current rating of 15 amps, and 15 amp fuses are the only ones I have on hand right now, but I would personally go with maybe like 10, 12 amp fuses. Because the INA260, this specific one from Adafruit, is anywhere from $15 to $20 per piece, so you really don't want to ruin that thing. So before getting into the wiring, first we need to install the library. So this library should be compatible with most Arduino boards like the Mega, Nano, and the Uno. In this case, I'm using the Uno R3. So with one side of the programming cable plugged into a USB port, plugging in the board, so that we can upload the sketch before getting to wiring the INA260. So to install the library, it is quite easy. Opening up the Arduino IDE and simply going on the books icon for library manager and just typing in INA260. The first result should be the Adafruit INA260 library. So just hitting install on that and saying install all for the dependencies. It should install in just a few seconds. However, just to make things easier for later in the video, you might as well want to install the Liquid Crystal I2C library as well. So to install that one, all you want to do is type in Liquid Crystal space I2C. And this very first result that comes up is the one that you want. So clicking install. Everything is now set up for the INA260 and the I2C LCD display. I always prefer to upload a sketch before wiring up the module, so to open up the INA260 sketch for the examples, you want to go into the File, Examples, all the way to the right at the top, the Adafruit INA260 library, and then clicking on INA260 Test. This will open up a new tab with a relatively small program. So now it's time to plug in the Arduino board so we can upload this code. So with the board now plugged into a USB port, the only step is to make sure that the correct board is selected. So in my case, the Arduino Uno board is already selected. And lastly, making sure that the port is also the correct port for the board. So in this case, it is also correct. So simply clicking on this dropdown and clicking Arduino Uno. So with all of that in place, just hitting upload. And just like any other program, it's going to compile and upload to the board. With the program now uploaded, it is now time to wire up the module. So with the sketch now uploaded to the board, just unplugging it from the power. So the breadboard I am using here already has something on it, but that's not going to be a problem. I just don't want to ruin what's already on here. So I will be using this entire blank area on this side. So the pins that we're going to be wiring up are going to be VCC, ground, SCL, SDA. We're going to skip the alert pin, and VN plus and VN minus are also the same ones, the same connections on the header pins here. So in this case, I will be connecting to the header pins and not using the VN minus, VN plus pins that go into the breadboard. So just simply inserting the board in a free space and the breadboard. So with the device now inserted into the breadboard, it's time to get an overhead view and start wiring up the connections. So the way the pins are labeled, they alternate up and down. So VCC, ground, SCL, SCA, alert, VBus, VN plus, VN minus. So to make this easier to follow, I will put the text on screen to make it easier to follow. So pin 1 is VCC, pin 2 is ground, pin 3 is SCL, pin 4 is SDA, pin 5, alert, pin 6, VBus, pin 7, VN plus, and pin 8, VN minus. So wiring up this board is very straightforward. Pin 1, VCC, is going to go to 5 volts on the Arduino. Next, the second pin, pin 2, ground, is going to go to ground on the Arduino as well. And pin 3 and 4, SCL and SDA, are going to go into the corresponding SCL and SDA pins on the Arduino. So pin number 3 is SCL, and this will go into the corresponding SCL pin on the Arduino. The pin right beside that, pin number 4, is SDA, which, like the one before it, is also going to go on SDA on the Arduino. Like that. So pin 5 and 6, alert and VBus, are going to be skipped. And VN plus and VN minus, while you can connect to them here on the actual breadboard, you can also connect to them via these header pins, which will give you full access to the 15 amp continuous current sensing ability of this board. So for that reason, I will not install it on the breadboard, and I will instead use a small screwdriver to insert the breadboard wires into the header pins. So looking at the board from the top, the one on the left is VN minus and the one on the right is VN plus. So I will be inserting a yellow lead into the VN plus port and then gently tightening it over the pin. Next, doing the same for VN minus with a green wire. So with the VN plus and VN minus cables connected, it's now time to plug in the Arduino and see what we get. So simply just reinserting the programming cable from before. And now let's take a look at the serial monitor. So going back into the Arduino IDE here and then opening up the serial monitor. Now you'll notice random characters coming up. That's because you need to switch the baud rate to, I think it was 115200. And now it should start giving some readings. And after doing that, you'll then notice that it's giving basically blank readings because there is nothing going through the system. So these little negative numbers here are completely normal, and the 0 bus voltage, 0 power, that is expected. So now that we know it works, I will now demonstrate how to properly connect a load to the INA260 to get a proper measurement out of this. So to test it out, I will be using this Bluetooth module. It's a Bluetooth audio receiver with this small 300 mAh lithium-ion battery. I have this tiny battery holder that can fit inside of the breadboard. So I will begin by inserting the battery holder into the breadboard. Next, just for safety, placing a 5 amp resettable PTC fuse on one of the battery terminals. So here is how to properly wire up a load to this INA260. So for this example, I am using a low power Bluetooth audio receiver module, and it has a positive and negative input here. And remembering from before, the VN plus was the yellow wire and VN minus was the green wire. So the first connection is going to be VN plus, and that is going to go to the positive of the power supply, or in this case, the battery. So the positive is connected to the PTC resettable fuse here. Next, I will take the load, which in this case is the Bluetooth audio receiver, and then connect the positive input of that to the VN minus. So the positive from the battery is going into VN plus, coming out of VN minus after being measured by the device, and then going to feed the load. So putting the positive of the load into the positive rail of the breadboard, and then taking that V in minus the green wire and also putting that into the positive rail of the breadboard. Now in this case, there is nothing else connected in the positive rail, because just like in an ammeter, you do not want to connect this directly to a power source. You always want to power it through the load. So now with the negative of the load of the Bluetooth audio module, we can either put that in the negative of the Arduino, the ground, or to make it simpler, because the battery also has a negative, we're going to put it in the negative rail of the breadboard. Because even if the voltage of the power source or the power supply is higher than 5 volts, you still want it to have a common ground with the Arduino. So with this brown wire connected to the negative pin of this battery holder, I'm going to also put that in the negative rail of the breadboard. Again, keeping in mind these are completely unoccupied rails. And now for the final connection, putting a wire into the negative rail of the breadboard and putting that into the ground pin of the Arduino. So connecting the negative of both the power source, so in this case the battery, and the negative of the load to the ground pin of the Arduino. So with everything wired up, it's time to insert the battery and take a look at the serial monitor. So we can see the Bluetooth module is turning on. So let's go and take a look at the serial monitor. So returning to the Arduino IDE and taking a look at that same serial monitor, we can see the readings are now coming through. So the current is being provided in milliamp units, the bus voltage in millivolts, and power in milliwatts. So the bus voltage, I want to make that in volts, not in millivolts, because it's a lithium-ion battery, and that's 3.66 volts here. So let's change that in the code here. So going right over to the INA260.read bus voltage, because 1 millivolt is 1/1000th of a volt, we can just go right after this command here, after the serial print read bus voltage, and just do a divided by 1000. Now we can re-upload that, and it should be giving it in volts. I should have changed this also to just the letter V. So let's do that real quick. You can see it's giving 3.66, but it should be saying V for volt, not MV for millivolt. So re-uploading, and it should be in volts now. 3.66 volts. So let's compare this with the multimeter now and see how close it is. So with the multimeter in volt mode, and 2 jumper cables connected to the alligator clips, let's connect it and see how it compares to the output of the serial monitor. So connecting the positive of the multimeter to the positive rail, and the negative to the negative rail, making sure to keep the 2 leads separated. And 3.672, let's see how that compares to the readout on the serial monitor. So the multimeter was reading out 3.672 volts, and over here it is reading out 3.66 volts. Now I want to increase that to 3 decimal points instead of 2 for a little bit more accuracy. So just going right after this 1000 here and putting a comma 3 and re-uploading. Now it should give 3 decimal places for the voltage. So 3.661 volts. And the multimeter off screen is still reading 3.672 volts. So in this case, it is difficult to tell which one is correct, so I will just assume that the INA260 is more correct. So with the readout here reading about 3.662 and the multimeter reading 3.672, it is almost exactly a 10 millivolt difference between the multimeter and the readout on the serial monitor. And the fluctuations that are happening in the milliamps here are simply from the Bluetooth module searching for a Bluetooth connection. This has nothing to do with the actual module itself. So now that the essentials of how this board works and how to work with it have been covered, I will finish the video by connecting an LCD display with code that I have modified from the code here to read out to the LCD display, and I will include that in the description of the video, as well as switching from this tiny little 5 milliamp load to a 65 watt heating element. And just opening a new tab in the Arduino IDE, I will now copy and paste the code that I modified. So what this does is basically, not only does it read out to the LCD display, but it also has like selective units. So for example, if the amount of current is below 1 amp of current, it will present it in milliamp units, but if it's above 1 amp of current, then it's going to present it in amp units. And then for the voltage, if the bus voltage is below 99 millivolts, it will present it in millivolts. However, if it is above or equal to 100 millivolts, then it's going to present it in volt units. And then finally, for the power in the milliwatts and watts, if it is below 1 watt, so 999 milliwatts, it will present it in milliwatt units. However, if it is equal to or above 1 watt of power, so over here, it will divide by 1,000 and present the units in watt units. And of course, all of this is also being relayed over to the LCD display, which will be connected very shortly. So with the battery removed and the Arduino unplugged, it's time to hook up this LCD display. It is an I2C LCD, so it only has 4 pins, which will make the connection very, very fast. And to speed up the process even more, I taped together these 4 wires here, so that getting all 4 pins connected is one step. So just making sure to align the blue cable with the ground pin. And all 4 are now installed. So connecting the LCD is just as easy as connecting the INA260 because they are both using the I2C bus. And I will show how the two are differentiated in the code in terms of their addresses later. So simply connecting the blue wire ground to the ground on the Arduino. And the purple wire, which was 5 volts or VCC, goes to the 5 volt of the INA260. So finally, the green wire is SDA and the gray wire is SCL. And on the Arduino, pins A4 and A5 also function as secondary SCL SDA pins. So that is where I'm going to plug these into, with A4 being SDA, and then the gray pin SCL going into A5, analog pin 5. And just like that, the LCD and the INA260 are connected. So because the program is already uploaded onto here, the serial monitor is no longer needed to see the information. We can see it all on the LCD here. So again, the battery is not inserted, so it's just going to give blank readings, but plugging in the Arduino again, we can see the same readings that we're seeing in the serial monitor before plugging in the battery. So now inserting the battery. So just like in the serial monitor with the new program that I very briefly mentioned, because the current is under 1 amp, it's being presented in milliamp units. The voltage is in 3 decimal places. It's always in volts unless it's under 0.1 volts. And because it's under 1 watt of power draw, it's being presented in milliwatts. So to demonstrate how this changes when I put something more powerful on the load, I will now swap out this very, very weak little Bluetooth audio receiver module, as well as the battery, and replace it with a 65 or 75 watt, it's somewhere in between the two, PTC hot plate. And this is where those external headers are going to become very useful, because that thing is pulling a lot of current. I think it's about 8 amps at its peak, so that is way too much for a breadboard. So before turning on the power supply, taking note of the units on the screen, where it's in millivolts, milliamps, and milliwatts. And as soon as I turn on the 12 volts, we now have wattage that's climbing. It's in volts now, and the amperage is in amps. This makes it very convenient because you no longer need to look at the serial monitor. So right before getting to the end of the video, I'm just going to show on the IDE how I interfaced both the LCD and the INA260 in terms of their I2C addresses. So here's the little code that I modified to work with the LCD display and also have that alternating units. So at the very top, the way that I address the two different I2C things is by addressing the liquid crystal I2C. It's by default, it's 0x27 as the address. And then this is the part that took me forever to find out how to do. To address the INA260 for its I2C address, you need to say hashtag or pound define INA260 all caps underscore I2C ADDR underscore default space 0x40, which is the default I2C address for this device. And why did the dictionary open up? So that is basically how I did it. And here you can see all of the attempts that I made, based on what I was copying from what I had done with the INA219. I thought I could carry it over, but I couldn't. So this is the end of the video on how to use the INA260 current and power sensor for the Arduino, as well as how to connect an LCD display to it. So thank you for watching, and if this was interesting or helpful in any way, please do consider leaving a like or subscribing to the channel for more of this type of stuff. And I will see you in the next one.